Okay, so now what we have here is here's the actual core that we're going to combinate. This is uncombinated, and the bottom line is, checking to make sure it's in the right keyway, it is. So this is uncombinated, which means there's no pins or springs, and it's not capped. So our job now is to physically combinate all 6 of these cores for this job. So let's put the key there. Let's put the core there. This capping block is going to be used when you get all of the pins and springs loaded. You're going to, I hope we have everything here. Yeah, we do. It looks like we do. So, first of all, these pins I ordered because this kit was deficient in some pins. This is a brass slide cover. And that brass slide cover, once you get all the pins and springs loaded in there, you're going to get this over this. You slide it in here, and what you do is you take that V-shaped spring cover and you hammer it down and you flatten it, and that's what holds it in. So you then, it's going to look like that. Okay.
Let me see if I can get you over to
that goes on there, and you just whack that with a very light hammer and you flatten it out. Is how that's going to work. So those are the springs, hopefully.
So Rich is actually in a meeting for about another 30 minutes. But let me send you to Jessica.
Falcon Springs. So I'm going to dump those here. I just want to get them put into the kit, and then we're going to dive into it. Then the covers. These are 6-pin covers. They don't fit in there at all. So I don't know. Yeah, we're not doing that. These might be 7-pin here. I probably should have checked that first. Yeah, they're clearly shorter. Okay, so cover. Yeah, I'm going to put the 6-pin covers back in here. I mean, a couple fit. That's probably enough for the job, so we'll figure that out. Okay, then what you can do is you can load up the rest of these pins. So as I had said earlier, Best calls them B and A segments, if I recall. B, I think, A might be the bottom segments. So these are 0.112, 9T. This kit is 9T, 0.112. So that is going to go here. This row is this row. Okay, so you'll be able to fit those. You'll be able to dump those pins in there because you'll end up needing them. Now, hopefully everything is in the kit that we need. So the first thing that we need to do at this point is take our bidding, our bidding chart so far, our pinning chart, and we're going to cut a key. So we're going to cut a control key and we're going to cut SKD1. So why don't you take that machine out of the box, and we'll play with this, and we'll go back to what we were talking about or saying earlier. And I've not cut on that machine in a little while, so I'll need to probably revisit it real quick. I'm going to grab a little hammer. Let's see that. And then our gauge, you know. Okay. Makes sense. Okay. So what I'm doing here is you're accustomed to loading the punch from the right side. Okay. This does not load from the right side because the carriage is set. Okay. It's moving from right to left, which means position 1 needs to be over here. So this key will load from the left, and otherwise the same method that you're already familiar with. So let's cut a control key. So that control key is 258737. So I'm just going to cut that. That should be a good control key. Now I'm going to cut one of SKD1, 537293. Five, 3, 7, 2, 9, 3. Now I've got one each of SKD1. Darn it. Okay. Now what we needed to do first was to combinate the core to the change key. And we're just going to do, as we had said, we're just going to do the first chamber. So 5. I need a 5 bottom pin. So right here. First chamber is at the end. Okay. Now what you'll find is that the pin didn't go all the way down, and it's because the control lug is not lined up properly for it to go all the way down. And you're going to end up needing, well, an ejector pin would be the proper tool. I don't know if we have our best kit here, or a paper clip is what's going to work. I'm just going to reach my hand underneath here because I know my paper clips are here. Or a very small drill bit also works. Okay, I got that pin all the way down now. I can feel it. Okay, so then the next, so we've got our 5 bottom pin because our first cut is a 5. Now, our control cut is a 2. So the math was add 10 to your control cut. 10 plus 2 is 12 minus your pin stack, whatever you got in there, which is 5. So we should need a 7 top pin. So a 7 top should be here. So we'll put that in the first position. Okay. I'm going to pull that key out. No, let's pretend it doesn't matter. Then we knew that we needed a 7. Then it's 23 minus everything that's in there. So we know we got a 5. We just put a 7. This is our initial pinning chart. So 23 minus 12 is 11. So I need an 11 top pin, which should be here. That's in there. Then I need a spring. So I'm going to grab a spring. Hitting small format will prove to be the most frustrating thing you do. And I'm going to hold that down with my finger. So now The control lug is sticking out, and I can no longer push it in. That would be good. I've got the change key in there, and it works. My finger is on the spring pushing it down, so I'm acting as if the spring cover has been tapped down. My change key works. I can pull that out. Now the key, the control key. If I stick that in and all I do is draw that back by a 15-degree clockwise rotation, then I know it's correct. Bingo. All that happens is my control key works. Now, if you had all 6 chambers done, you would slide that, you would get a spring cover. Not these are 7-pin. You'll notice that they're too long. You can't use them because they're longer than what the 6-pin core allows, and they'll hang off the back. You could take, if you got into trouble, you could take one of these and just get your heavy-duty snips, you know, not scissors, but heavy-duty versions, and just snip it down. It would be fine. But we don't want to do that. We just want to have the right parts. So at that point, slide cover. This is called a capping block. You put this piece right on there. You get the idea. Boom, and you tap it a couple of times. You then very carefully visually inspect your job. If that spring cover, if the slide cover comes off, if it bursts out because it's under spring tension, it will fail, and the customer will not be able to use their lock how they're expecting to. So this is absolutely the art craft of locksmithing. This is more like real locksmithing in the sense that you're doing something that actually anyone can load pins. But understanding these advanced topics and then doing it with the art and skill in your hands to make sure that it works correctly, that's locksmithing. So now we're doing locksmithing. So the next thing to do for you is I just want to close this. This gets knocked over and the job stops. Because I think I may have enough. I moved so many of my pin kits to storage, I don't really have them here. So the next thing to do now is complete your pinning chart. So we're going to complete the pinning chart together, just because it's been a week since we've talked about this. And then, as I had said earlier, if you were to do a large enough job, you're probably going to want to fire up Google Sheets, or whatever they call it, because you get nice boxes, and I can show you how to do that. Really simple math. So
A, B, supply.
1, 2, 3, 4, 5, 6. So the key tags I had mentioned earlier,
Give you an update.
you're going to need 6. It would be nice if I had my control stamp, a stamp, bam, which I don't have here. I'm not worried about it because I know that these are temporary cylinders for the client. This client is in Australia and they don't use these. And the guy's like, oh, I'm doing this job in Australia but with North American hardware and I don't have these cores. I didn't know I needed them. Okay, so we've done the pinning chart for chambers 1 and 2. We've combinated chamber 1. We know it works. What's going to happen is you're going to load pins and it's not going to work. And you're going to come to me or Terry and say, it doesn't work. Why doesn't it work? It's not going to work because the pins are wrong, and you can't, because we don't have X-ray vision, we can't see inside of there what's wrong. The pin might be too long or too short, but it's going to probably be a pin problem. If it's not a pin problem, when they manufacture these cylinders, there's lots of drilling, lots of microscopic shards of metal left hanging around, and sometimes that stuff gets in the way. But the bottom line is we are using Falcon original cores with known compatible, with a pinning kit from a manufacturer who engineered that pinning kit specifically to be compatible with Falcon. And we're using Kaba Ilkel key blanks, which I know, which are completely compatible with the system. The reason I say all that is because we could be working in a Aero environment or a Best environment where the cores and all of the components are Aero or Best. I like Falcon because that's, as I had said earlier, that slide cover is a single piece. With Best, what you have to do, if you recall, I showed you that other core that had 6 or 7 little holes in the top. You must take that small little piece of brass, round little piece of brass, and you must tap them in individually. That's a hassle. That takes it's not a big deal, It just takes more time. And I like the slide cover version because it's faster. I cap them all at once. Okay, so now we wrote our pinning chart. We wrote chamber 2. So let's just review it. We know that we've got a 3 in the change key. We've got a 5 in the control key. So we know you're always going to drop for this job. Whatever the bitting is for the change key, it will always be your bottom pin. Always. Not if we were master keying. But we're not in this job. You're only making 2 keys work this time, 3 or more. So on this job, these will always be your bottom pins. A little trick. So 3. Okay. Then the control cut is 5. Add 10. 15. 15 minus 3 is 12. That's your next pin. 23 minus 15 is 8. That's your next pin. Spring. Change key, test it. Change key comes out. Control key in, test it. Control key pulls the lug back, take it out, go to the 3rd chamber. That's how you're going to do this. Let's finish the pinning chart for the rest of this key, and then you will do that, and then you'll come back to me and I will write the rest of these numbers, and then you will write all the pinning charts, and I want you to stay on this job today until it's basically done. Today, hopefully today. So what's the pinning chart for the 3rd chamber? You know what's worse than losing your Z-axis on your CNC machine? It's not participating in the Architectural Builders Supply March giveaway.
+7 on the bottom.
Yep.
And then +10 is 17.
10 to the control cut.
Oh, so that's...
Sorry, that's an 8.
Oh, sorry.
So control cut plus 10. Subtract from that all the gobbledygook you already have in the chamber. Right now you got 7 in the chamber.
So it was 18 minus 7.
You got it. So that is. It's okay. You know why you got these?
Yeah.
Yeah, to use them. I still use them.
So it was 18 minus 7? Oh, 11.
They were very good. The bottom line is this literal 2nd grade math is going to be the difference between you doing it right and you doing it wrong, because no one is good at little math like that. It's harder than it seems. So now the next thing is magic number minus all the gobbledygook in there. So the magic number is 23. 23 minus what?
18.
You got it. So what is the driver pin? 23 minus 18.
5.
You got it. You use your fingers. I love that. I really love that. So, give me chamber 4.
2.
Yep. Sorry. So 2 is the bottom pin. Yes. Your control cut is 7. So what's our control pin?
15.
Yep. 23 minus your stack.
4.
Nope. What's your stack?
17.
Yep. 23 minus 17.
Oh, 6.
Yep. Give me chamber 5. Hold on. The reason that Google Sheets or Excel is nice is because I'm not writing very evenly. And when you write the rest of these, you might draw lines or however you want to do it. Or I actually have graph paper, so that you might want that. And actually, I would probably encourage that. So the Google Sheets are nice because you can formulate these cells with this basic math, so you don't have to do this in the future. If you get a big job, if we get a big job that you're going to keep 5 and 6.
9.
Yep.
And it's 13 minus 9.
Yep.
4.
Yep.
10.
Yep.
And 30.
Yep. Control cut plus 10 minus your pin stack.
What would that be? Oh, sorry. I was looking at the 6.
Yep.
14.
Yep. And then your driver pin. can I give you a tip? In your control cut, you have 2 cuts that are the same. That's generally going to give you a tip off as to what they will always be. So 23 minus 17.
A, B, supply.
23 minus 17 is 6. We got a 7 cut here and a 6 here. You'll start, and a lot of locksmithing is indeed identifying patterns. So what you're going to do now is you're going to take all of this and you're going to move to your place, to your position, and you're going to
send you to someone who can
you're going to
help you
combinate the rest of this cylinder, doing them one chamber at a time. Many things can be wrong, and I will suggest to you that before you start dropping pins, that you check the math of all of these every time, because something's going to not work, and you're going to look at pins and wonder if it's the cylinder, and then you're not going to look at your simple math and realize I was off. My simple math was off. So my suggestion is you build your pinning chart, you double check your pinning chart, you then start to combinate.
I see we
so
had a voicemail from you.
You will. I didn't write down the rules, so it's 1. What is your bottom pin? 2. What is control pin equals control cut plus 10 minus pin stack. Don't worry about these abbreviations. Hey, what does CC mean again? I won't remember. 3. What is driver pin equal?
No worries.
23 minus pin stack. Pin stack is just what you've already put in there. That's what the pin stack is. This is frustrating. This is time consuming. Everything you know about pinning locks, multiply it by 5 in terms of how long this takes. The first time
That's
that
right.
Terry's pretty good at capping these as well, and you can show him,
Bradley.
you can show me. And then since we're here,
Yeah,
let me just add the rest of the change key numbers. So I'm going to use a system called the rotating constant. And rotating constant is an advanced topic, but it's very simple and very secure. And I'm going to rotate. I'm going to rotate 2
It
positions.
does come with the clip, yes.
So what that means is I'm going to do 5, 3, 7, 2, 1, 5.
What size fire extinguisher do you have?
5, 3, 7, 4, 9,
How many pounds does it hold?
5, 5, 3,
So
9,
that's the question, yeah. That needs 10 pounds.
2,
Yeah.
9, 5, 5, 5, 7, 2,
Not
9, 5, 7, 3, 7, 2, 9, 5. Okay, doesn't matter what I did right now. It's called rotating constant. I'm moving 2 positions. This will yield me a very secure cylinder with the minimum amount of ghost or incidental keys, and allows us a little bit an easier time because we're reusing a lot of the numbers of our first
So the
change
2 part
key
numbers you
is what we're
mentioned are
doing.
for 2 different sizes.
So it doesn't matter, but
but
it's a fascinating topic that I think you would love at some point. So 5, 3, 7, 2, 1, 5, 5, 3, 7,
number you gave me is for a 20-pound extinguisher.
4, 9, 5, 5, 3, 9, 2, 9, 5, 5, 5, 7, 2, 9, 5. Okay. Oh, 7,
The 2 items.
3,
or from the
7, 2, 9,
extinguisher?
5. Yeah, I'm good. My numbers are good. So feel free to rewrite this.
Okay.
Feel
and
free
the
to.
material you were quoted was
You want
correct.
graph paper? If you do, it's just down here. So your job now is to pin the rest of this cylinder so you feel like, oh, okay, I can do this. Then write the rest of your pinning charts, do all
Okay.
that math at once, and then all you're doing is loading pins.
Okay.
What questions do you have? That, and you, if you aren't asking 100 questions as you're going through this, the real problem will be someday you're going to say, oh, I can't remember how to do that. And we're going to go through this again. Even today, I needed to remind myself, how does that machine work? Because we don't do small format often enough to be able to just do it. At least currently we don't. So I will help you move all the stuff over there, and you'll proceed accordingly.
Yeah, the strap
do you want a piece of graph paper?
5 and 10 pound
Okay, it is. I think it's the quarter by quarter, so it's a little smaller. A pencil would probably be better because it will bleed less.
Absolutely.
But it will force you to be completely organized. Awesome. Let's do that.
And this is simple.
All right, so you got one. Let me take a look-ski. Yeah, think of this as pass or fail. It either works or it doesn't. Yeah, I would say if you're not sure about your spring cover, literally try to peel it back a little bit. And I might give that a little extra tap myself. I might tap it down one more time. Control key works really good because there's a lot of force pushing on that. That works well. Hey, you're great. That's awesome. I would probably give that one more good crack. Flatten it down just a little bit more. That's what I would suggest. Oh, your key tag will say SKD1 on it. You'll insert the key into there and turn it, and that would be good enough. What you could do is you could, and it wouldn't be a problem, is use this marker and write on the brass side of it SKD1. You know, just anywhere. Let me take a look and see what I would do. Yeah, I would be uniform. Whatever you do, do it the same way every time. Write it on one side of this. That's all. You could do that. Awesome. That worked. That worked perfectly. So in conclusion, the job was finished without any errors, without any mistakes, without the need to do any redos or do-overs on the cylinders. They all were pinned up correctly by the person that we've just taught how to do it. And the only thing beyond what's already been done that is left to learn is simply when you're going to master key or grandmaster key or great grandmaster key, something where you'll have more than just 3 total pins in a chamber. You're always going to have a bottom pin, you're always going to have a control pin, you're always going to have a driver pin. I mean, unless there's some instance where you don't have something, you're going to have those 3 pins, but that means you'll have 3 pins to make 2 keys work. Well, what if I had a change key and a master key and a control key? Now there's 3 keys. You may or may not have more pins per chamber because in the rotating constant method, you would have more pins in at least one additional chamber or more. But if you have additional pins in every chamber, then you have total position progression. So in order to make a change key and a master key and a control key work, you might not have 4 pins in every chamber, and in fact it would be best practiced if you didn't. But you'll have another pin in at least one chamber. So let's switch to the desktop camera view and let's take a look at what would be left, and then we'll summarize the formulas about how you go about doing this. You know what's worse than not knowing where to put the neutral leg on a 3-phase high voltage panel? It's not participating in the Architectural Builder Supply March giveaway. Okay, so I don't recall the actual change key that we were using, so let's just write control and let's write SKD1. No, actually no. Let's write 1AA because we're going to have an AA. So let's make 1AA. And then let's have AA to be, we'll do rotating constant. So we'll make it So this would be rotating constant in the sense that you'll notice that I've got the same biddings in the change key that I do the master, but not here. And I forgive me, I've kind of written this out of sequence. So let me do this. Two AA and a rotating constant where I'm rotating one position would be 3, 8, 4, 7, 3, 5. Where this rotation in the 6th chamber is now in the 5th chamber. A 3 AA would be 3, 8, 4, 2, 1, 5. Now this, no, hold on. Actually, let's take a look at that. 3, 8, 4. Yeah, I wrote that wrong. Let's make it 3 AA would be 3, 8, 4, 9, 1, 5. That rotated 6th chamber, 5th chamber, 4th chamber. You can guess 4AA would rotate the 3rd chamber. So I'm just I'm rotating the chamber that is going to change. The advantage of rotating constant is that you are not adding unnecessary master pins in every chamber. If you were doing total position progression, 1 AA would end up being something like 5, 0, 6, 9, 3, 7. And all I did was change in 1 AA, I went 2 away from the master key in every position. That's an unnecessary amount of master pins. Okay, all of that aside, it doesn't matter. What the job to do was to write a pinning chart for what was SKD1 and the control key. So the pinning chart would be 3. Let's see, we're going to have driver pin, control pin, and bottom pin. Let me move that up a little bit. Okay. So in this system where there's just going to be one key that works, we're doing 1 AA, which is really SKD1, and the control. So the bottom pin is always going to be the pin for our change key. So it's always going to be 3, 8, 4, 7, 1, 7. You add, and we'll just do the first chamber. You add 10 to your control cut, so that's 15 minus your pin stack is 12. 23 is your magic number minus your pin stack. 23 minus 15 is 8. So the rule is 1. What is your bottom pin? Bottom pin is a 3. 2. What is your control pin? Equals control cut plus 10 minus pin stack, which is control cut is 4. 5. 5 plus 10 is 15, minus your pin stack is 3. 15 minus 3 is 12. 3. What is your driver pin? Equals 23 minus pin stack. 23 minus 15 is 8. That's where the 8 comes from. Now, the only thing that would change here is if we were doing an AA and a 1 AA. So what's going to happen is, I'm just going to rewrite what I have here. So C control equals 5, 4, 7, 2, 3, 8. Now we're going to have an AA and a 1 AA. AA was 3, 8, 4, 7, 1, 5. 1 AA was 3, 8, 4, 7, 1, 7. So now, using our rules, the rules have to change a little bit. It's no longer what is your bottom pin. We're going to have 4 rules. What is your bottom pin? 2 will be what is your master pin. 3 is what is your control pin. And then 4 will be what is your driver pin. So in this scenario, what is your bottom pin? Well, your bottom pin is the lowest of what's here. So in this case, your bottom pin is going to be a 3 because that's what we've got. Bottom pin equals 3. And because this is rotating constant, you're not going to have a lot of master pins. So 3. I'm sorry. Let's do the chamber that actually is rotated, and it's the 6th chamber. So we're doing this chamber here. So 8, 5, and 7 are the cuts. So what's your bottom pin? Bottom pin is going to be a 5. It's the smallest number. What's your master pin? It's going to be a 2. It's 7 minus 5. What is your control pin? It's going to be 18. 10 plus 8 is 18. Minus your pin stack is 7. So that's going to be 11. And then what's your driver pin? It's 23 minus your pin stack. And that's going to be 5. 23 minus 18 is 5. So that's the only change. That it doesn't become any more complex than what we just wrote. The only thing that would make it more complex is if we had a 3-level system where it was A, 1 AA, or a 4-level system, GMK, A, 1 AA. Actually, it would be not 1 AA, forgive me. It would be A, 1, GMK, A, 1 is what it would be. When it's a 3-level system, you put the number after the letters. Forgive me. The point of the matter is, what you see is as hard as small format really gets. Lots of advanced tips and tricks and techniques that I may have learned at some point and will recall at some point. And the greater art of this system is something that is to be learned and pursued through your career. But this is the basics. And dive right in. The water's fine, and hope you enjoyed this. Thank you. Do you know what's worse than getting sick from a coworker? It's not participating in Architectural Builders Supply March 10,000 YouTube subscriber giveaway.